Welcome to Geometry again. This is Mr. O'Shea. Today we're going to be going through 1.2, and in the discussion of 1.2 we're going to be talking all about points, lines, and planes. The most fundamental piece of geometry that we need to first talk about is a point. And a point, all it is a very specific location. Now, points have no size, they have no shape. All they are is just a point, like we said, a very specific location. And when we name them, we're going to go ahead and always name our points with capital letters. So this first point here in blue that we have, we're going to go ahead and name that one point B. And remember, point B has no size, it has no shape. All it is a very, very specific location. It tells us where to look. All right, the next geometric idea we're going to talk about is space. Now, what space is, it's basically the set of all points that we're talking about. So you can think of it as basically like if we had a whole bunch of points, A, B, C, so on and so forth. Where do they all lie? Where do they all take place? Well, they all take place somewhere, and what we're talking about is really the space that they're in. Now, if we want to be a little bit more specific about space, we're going to start talking about lines. And essentially, a line is a series of points, at least 2 points. It's going to be a series of points that extends forever in opposite directions. So again, a line is a series of points that extends in 2 opposite directions. And we'll go ahead and look at a couple of examples of a line. So take, for instance, if we threw a few points out there that were, in fact, extending in opposite directions. So we've got point A, B, and C, which all lie on one line. That big yellow line right there. Now, when we name these, we're going to use at least 2 points on the line with a little line marking above it. So we could call this line AB, because A, B are on that. We could also call that line, say, line BC, 2 points on there. And in fact, we could call it AC. We could get rid of B altogether. As long as we have 2 points on the line, we can call it that. And another way to go ahead and name this is actually if we bypass the points altogether and we focus really on the little subscript, the little lowercase cursive t, we could also call that line T. So again, the 2 ways to name a line are to pick any 2 points on the line, like line AB, line BC, line AC, so on and so forth, or to go ahead and name it by the small cursive letter that's attached to it, so line T. All right, when we're dealing with points, we can have these things called collinear points, and collinear points really aren't too hard to kind of think of the idea behind it, because collinear could be broken into 2 parts, co and linear. And co, just meaning that they're together, linear means line. So collinear points are points that lie on the same line. Now, if we look at a couple of examples here, we've got 1 point here, 1 point here, and a 3rd point down there. We'll call it point A, B, and C. Now, I can go ahead and extend one line that goes through all 3 of those points, so we can say that those are collinear points, lines that are points that are on the same line. Now, we can contrast that with these 3 points over here in blue. If I extend a line, let's go ahead and name those. We'll call it X, Y, and Z. Let's make that X a little better there. There is no one line that I can extend that hits all 3 of those points. So that tells me that those are, in fact, not collinear. But A, B, and C are collinear points. All right, so to recap, we're talking about lines and points here. Now, lines need to have at least 2 points. They need to be made up of at least 2 points. And to name them, we need to name 2 points on that line, and we're going to do it with a little line symbol above it. So if I asked you to name this line, you can give me any number of answers. You could say that it's line AB with a little line symbol over it. Or you might say that it is line BA with a little line symbol. Now you might also be able to name it line, sorry, let's get that line a little, line L with that lowercase l. You cannot name it line B. It's unacceptable because you need to have at least 2 points. You also cannot name it line LA because L is not an actual point on that line. You need to have 2 points when you're naming it. And on top of that, we talked about collinear points. We see on this one that A and B are on the same line, so A and B are collinear. If we added on a couple of more, let's say point C, we can say A, C, and B are collinear points. We can even throw in another one, W over here. W, A, C, B are all collinear points because they're on the same line, line L. Now if we threw another point, and let's say we threw that point way up top, and that's point Z, you can see that W, A, C, B, and Z are not on the same line. So if I asked you if those are all collinear, you would say no, they are not collinear because the Z kind of messes everything up on that one. And with the added letters in there too, if you wanted to name it, you could have named it line WA with the line symbol, or even WC. You can skip letters in there. That's perfectly fine. In that same token, you could say WB or BW. Hopefully you guys get the idea. Any points that are actually on that line would be perfectly fine to use. Alright, so moving on, we have a little example here. The question is, are points E, F, and C collinear points? Well, let's go ahead and look. There's E, there's F, and there's C. And I could draw one line that hits all 3 of those points. So the answer is yes, they are collinear points. Remember, co and linear, co meaning together, linear meaning line, they are all on the same exact line. Let's look at that second example there. We're just going to change one of the letters. Now we're going to go ahead and use the letters, the points. The points E, F, and D. Are E, F, and D collinear? Well, I need to be able to draw a line through all 3 points, and only one line. Now if I try, I could draw a line through E and F, but it doesn't hit D. Or I could draw a line through E and D, but it doesn't hit F. And I could draw a line through F and D, but it never hits E. So there is no one line that I can draw and hit all 3 points, so my answer is no. E, F, and D are not collinear because there is no one line that they all share. So now in our discussion about points and lines, they need somewhere to be located at. And that's going to be called a plane. Now a plane is just a flat surface, and this specific flat surface, it has absolutely no thickness to it. So it's basically an imaginary surface that has no width, no thickness, and it extends forever in any direction. And it's basically the area where all points and lines actually lie. And just like we had collinear things, we can also have coplanar things. Now coplanar things, hopefully you can figure that out from the collinear, it's just going to be 2 lines or points, basically it's 2 of anything, that lie on the same plane this time. Instead of collinear being same line, coplanar means same, together, plane. So we can have points on the same plane, we can have lines on the same plane, and we'll go ahead and take a look at an example of that right now. So here we have an example of a plane, and it's just that flat surface where the points A, B, and C are located. Now we name planes, we're going to name planes with at least 3 letters. So this could be plane ABC, which is comprised of points A, B, and C, which A, B, and C being the fact that they are on the same plane, we can say that A, B, and C are all coplanar. Now we can extend it one more kind of level and say that line AB, if we make that line between A and B, And let's go ahead and connect a couple other points here. Let's go ahead and say line AC. Sorry, I didn't quite make it through C there. Line AC are also coplanar. They're two lines that lie on the same plane. So again, you can name this with the points A, B, and C and say this is plane ABC. You can also name it plane BCA or plane CAB. It doesn't really matter so long as you have 3 points. Now, one other note that I do want to bring up to you guys is the fact that this also could have a uppercase letter in it. So just like a line had a lowercase, maybe line AB is really line L, or line AC is really line W with lowercase cursive letters, planes, on the other hand, are going to have uppercase cursive letters. So instead of naming it plane ABC, we could have also named it plane R, being that it's a cursive R. Uppercase cursive letters, again, are planes. Lowercase cursive letters are lines. So here we have an example here. Name this plane. We can pick any letters. I'm going to go ahead and name this one plane TSR. 3 letters. Any 3. I went in a clockwise direction, as it's pretty standard to always do. You could also name it plane SRU, or perhaps plane UTS. Doesn't really matter so long as you have at least 3 points on the plane. Now you could have named it plane RUTS. You could go with more. It doesn't matter so long as you have at least 3 points on that plane. So this one's a little trickier. I want to go ahead and name the front plane. I'm going to go ahead and shade that front plane in. You see the box shape there, and we're going to go ahead and shade in that front one. Now that plane, we can name it a couple of different things, but we want to name the points that are actually on that plane. If you guys see, like point H, it's nowhere on that plane. We can't use it. So I'm going to pick any 3 letters, and I'm going to go ahead and say that this is plane EFB. Hopefully you guys can see some other names for it as well. We might have been able to say plane, let's pick 3 different letters that are on there. Plane BAE, or perhaps FBA, or AEF. Any 3 letters, so long as you go clockwise and they actually are on that plane. Now you absolutely could not have used perhaps GFB, because GFB, if we use those, it's actually talking about that plane on the other side. Different plane, wrong answer, right? So we're only going to use these ones that are actually highlighted in the blue or on the orange front plane. All right, now the big crux of geometry. There's a handful of things that we just know, right? And those are called postulates and axioms. And postulates and axioms are accepted statements of fact. You don't have to prove these things. They are believed to be true no matter what. So that could be something like, the sun is going to come up tomorrow. You don't necessarily have to prove it. It's just accepted as a statement of fact. So postulates and axioms are statements of fact. Now the first postulate, the fundamental postulate of geometry, is going to be the fact that through any 2 points, pick any 2 points in the world, through any 2 points, there is exactly and only going to be one line. So again, through any 2 points, there is exactly one line. So if we look at the point A and point B down there, again, you can use any letters, I just keep using A and B. There's only one line that I can draw that's actually going to go ahead and make it through line A and B. Can't draw any others. We're going to go ahead and name that line T. There are no other lines that would actually go ahead and hit through line A and B. I'm sorry, through point A and B. The next fundamental postulate, postulate 1-2, states that if 2 lines ever are to intersect, if they're ever to cross each other, any 2 lines that actually go ahead and meet, they do so at a very specific point. So if 2 lines intersect, they intersect at exactly 1 point. And we'll go ahead and look at a little picture diagram of this right now. We'll take one line here in purple, and we'll call that line A and E. And if that were to cross with this line in yellow here, let's say that that's line D and line B, it actually only meets when they cross, they intersect at exactly 1 point. That's going to be point C. So anytime that two lines ever intersect, they intersect at exactly 1 point. Now to further 1-2, we got postulate 1-3. And instead of talking about lines, this time around we're going to talk about planes. And anytime you have two planes that intersect, so as you see in that picture down there, we got two flat surfaces that kind of cross each other. Anytime you have two planes that intersect, they do so at exactly, not 1 point, but they do so at exactly one line. So here we've got one plane. We can call that plane RTS or STR, again naming 3 points that lie on that plane. And you've got another plane, plane STW or WTS. And as you can see, they only actually intersect at one very specific line, and that's going to be line ST or line TS. So when two planes intersect, they do so at one line. Now I'm never going to ask you guys to actually prove that because it's a postulate, it's an axiom, it's actually just accepted as general fact. And the last thing that we're going to go ahead and hit on in this lesson is postulate 1-4. And what postulate 1-4 states is that through any three non-collinear points, remember 3 points that are not on the same line, very important for this one, through any three non-collinear points, there is exactly one specific plane. So through any 3 points that are not on the same line, there's only exactly one plane. So if you took any 3 points, and these 3 points are not on the same line, we'll name them A, B, C. I can go ahead and draw one plane around them. Now, drawing them out might not be the best picture for it. I guess the best way to do it would be that if you had 3 tennis balls, you can put them on any 3 surfaces, make them at different heights so that they're not in the same line. You can extend, if you can think about like holding a piece of paper, you can actually extend one flat sheet of paper, if you had a big enough one, that would hit all 3 tennis balls if you held it the correct way. Talk a little bit more about this in class. Go ahead and finish the rest of the packet, the rest of those example problems, and have them ready to go for tomorrow. See you guys.